Modern submarines are the safest ever built. Redundancy is layered into every system. Sensors watch sensors. Automation monitors human error. Safety doctrine has been refined by decades of loss. And yet, even in the modern era, submarines still come within minutes of disaster without firing a shot or being attacked. The reason is simple. Modern submarines do not usually fail violently. They fail quietly. Small technical problems are absorbed by automation, masked by redundancy, and delayed by procedure. The danger now lies not in obvious catastrophe, but in the space between detection and response, where a manageable fault can become a fatal chain reaction. This episode examines the near misses that almost sank modern submarines and the procedural lessons that reshaped doctrine after the Cold War. These are not stories of heroics or enemy action. They are case studies in discipline, reporting, and the uncomfortable truth that technology does not remove risk. It changes how risk hides. In November 2017, the Argentine submarine, San Juan, reported an electrical fault in its battery system shortly after snorkeling. The report described seawater entering the battery compartment through the ventilation system, causing a short circuit. The fault was acknowledged and logged. The submarine was instructed to continue its patrol while monitoring the issue. From a purely technical standpoint, battery faults are a known risk on diesel-electric submarines. Procedures exist to isolate damaged battery sections and continue operating safely. What made this incident dangerous was not the fault itself, but the delay in escalation. The report was treated as a contained technical issue rather than a developing emergency. Modern submarine doctrine increasingly recognizes that paperwork and communication are part of damage control. When reporting is delayed, minimized, or filtered through assumptions, physical systems often fail next. The lesson reinforced after San Juan was procedural rather than mechanical. Fault reporting must be treated as a live emergency process, not an administrative task. Near misses often begin with language that understates risk. A minor fault becomes a degraded system. A degraded system becomes an emergency when conditions change. Modern doctrine now emphasizes early escalation, conservative assumptions, and command responsibility for interpreting technical reports pessimistically rather than optimistically. In 2001, USS Greenville collided with a Japanese training vessel during an emergency surfacing maneuver. The submarine was conducting a demonstration under time pressure with observers on board. Safety systems were available, but procedural discipline broke down as timelines compressed and responsibilities blurred. The failure chain did not involve equipment malfunction. It involved skipped steps, incomplete contact verification, and the assumption that conditions were clear because sensors showed no immediate threat. The collision exposed a critical vulnerability in modern submarines. Transitions, surfacing and diving remain the moments when risk concentrates fastest. Following the incident, doctrine was revised to reinforce procedural pacing over operational tempo. No demonstration, exercise, or schedule now justifies shortcutting clearance procedures. The lesson was blunt. Modern submarines are safest when moving slowly through transitions regardless of external pressure. A year later, HMS Trafalgar ran aground during a navigation exercise. The submarine was not under attack. Systems were functioning normally. The failure occurred because digital navigation data was misinterpreted and insufficiently cross-checked against traditional methods. Automation had reduced workload, But it had also reduced skepticism. Crew confidence shifted from independent verification to system trust. The grounding forced a reassessment of how modern crews interact with digital systems. Sensors do not eliminate the need for judgment. They demand better judgment. Modern navigation doctrine now emphasizes sensor disagreement drills, manual plotting proficiency, and deliberate distrust of single-source data. Redundancy only works if disagreement is expected and investigated, not ignored. Fire remains the most persistent internal threat aboard modern submarines. High-energy electrical systems, dense cable runs, and complex electronics create ignition risks that automation cannot remove. Several modern submarines across multiple navies have experienced onboard fires that were contained only through rapid isolation and strict adherence to damage control doctrine. The procedural shift here is critical. Modern fire response prioritizes immediate compartment isolation over investigation. Crews are trained to assume worst-case fire behavior and act instantly. Firefighting underwater is no longer about locating flames. It is about preventing spread before confirmation. This doctrine reflects a broader modern trend. Submarine safety no longer waits for certainty. It acts on suspicion. The cost of false alarms is inconvenience. The cost of hesitation is loss. Nuclear submarines introduce a different category of near-miss. Reactor scrams or emergency shutdowns are designed to be safe events. From an engineering perspective, a scram protects the reactor. From an operational perspective, it removes propulsion, power margins, and tactical options. A modern submarine experiencing a scram is not in immediate danger, but it is vulnerable. Drift, loss of maneuverability, and reduced situational awareness can turn a safe shutdown into a secondary emergency if crews are unprepared. Modern doctrine treats scrams as survivable but hazardous states. Crews train extensively to manage silence, restore propulsion deliberately, and avoid cascading failures during recovery. The lesson is procedural. Even safe systems can create danger if recovery is rushed or poorly coordinated. Across all these near misses, a consistent pattern emerges. Modern submarines do not fail because safety rules disappear. They fail when discipline erodes, reporting lags, or automation is trusted too completely. As a result, modern submarine doctrine assumes that sensors will fail, humans will misinterpret data, and automated systems will hide developing problems. Training emphasizes skepticism, cross-checking, and early escalation rather than reaction. Modern drills replicate worst-case scenarios because history proved that normal conditions offer no warning. Crews are trained to respond to ambiguity with procedure, not confidence. Checklists are intentionally unforgiving because optimism is the enemy of safety at depth. Submarines today survive not because accidents stopped happening, but because doctrine now anticipates failure as inevitable. The ocean has not changed. Physics has not softened. The difference is that modern submarines remember what earlier crews paid to learn. Near misses matter because they expose the gaps between design and behavior. They reveal where technology ends and responsibility begins. And they remind crews that the most dangerous failures are often the ones that look manageable, right up until they aren't.